Assalamualaikum warahmatullahi wabarakatuh.
We are from Group 5 in Class D, English course in Mechanical Engineering Study Program from Engineering Faculty at the Muhammadiyah University of Yogyakarta. We want to explain the video about factors the effect welding.
Okay, before that, we will introduce ourselves to our group member. I am HARDANY IKHSAN.
I am ARIF CAHYONO.
And I am SAGARA PRATAMA. Okay, here is the video about factors that affect welding.
A good weld bead versus a bad weld bead. Creating a good weld is a combination of properly adjusting the controls on your machine, using good weave techniques, and correct travel speed. Set your MIG welder according to your welder's setup guide. Some fine-tuning may be required. Adjusting machine settings. This is how a good arc sounds and looks. It has a good balance of welding wire speed and voltage. Notice that the resulting bead is slightly convex and there's a smooth transition at the toes. This is an example of how the arc sounds when you have too much wire feed speed. Notice how the bead is irregular, sits up higher, and even has a lot of spatter. You'll also notice the transition at the toes is not as smooth. To fix this, either increase the voltage, which will burn off the wire faster, or decrease the wire feed speed. It's best to adjust one of the parameters for easier control. This is an example of how the arc sounds when you have too little wire feed speed. You'll notice that the resulting bead is wider and it may be a bit convex. To fix this, either decrease the voltage, which will burn off the wire slower, or increase the wire feed speed. Weave techniques. When you're welding two pieces of steel together, the material you are welding actually melts. Good welding technique would include a slight weave to blend those two molten metals together. This is an example of a slight weave on a T-style joint. You rock between the two pieces slightly. This is an example of a half-moon weave technique on a T-style joint. You can experiment with these techniques to get the look that you want. Here's an example of using circles. The resulting weld looks like coins laying down in a row. Travel speed. Travel speed is an important factor when making a good weld. If you travel too fast, the weld may not hold. If you travel too slow, you could get too much penetration and maybe even burn a hole in what you're welding. As a general rule, you want the side of the bead buildup to be as thick as the thinnest material you are welding. For example, if you're welding 1/8 inch material to 1/4 inch material, the bead height should be about 1/8 inch. The height is from the top of the crown of the bead to the crack in the joint you're welding.
Okay, after seeing the video, what are the factors that affect the quality of welding?
In principle, the purpose of welding is to make metallurgical bonds between the base material at the welding electrodes use stroke heat energy. The source of heat energy used can come from gas, combustion, or change in electrical energy. The main requirement is that heat energy must be higher than the melting point of the base material and electrode.
Last is local connection. The welding process usually relies on heat energy with a temperature ranging from 200 and 300 degrees Celsius. At the temperature, the welding will undergo a giant smelting process. The result is an acid metal metallurgy bond. With effect, the quality of welding result, there are two factors. The first point is welding technique. The main factor that determines how well welding quality is carried out by a worker is the welding technique used. This factor has a direct effect on the result of welding work. Some aspects related to the welding technique include the position of welding, the speed of welding, and the shape of the seam joint. Not only this aspect, the stage of the weld electrode and the welding brother should also contributed to how near the welding work is done.
The second point is metal. Before being weld, the metal must be subject to heat first until it melts and its form turns to milk. Interestingly, the nature of the metal being connected is also influenced by the cooling process again. If the metal cools slowly, it will turn chewy, whereas if it is suddenly cooled in a fairly fast time, the characteristic of the metal will become brittle. Chemical changes that occur in the metal are caused by the arrangement of the element in it, especially the carbon or C. This is because metal that melt at high temperatures contain more gas than metal that melt at low temperature. As a result, roundness welding will cause porous effect. To prevent the occurrence of loss, the protective metals or flux need to be added while the welding process is in progress. Also, try so that the metals that will be connected have the same melting point. As a result, the process of making weld joint.
Okay, the third point is the influence of heat. The effect of heat on welding joint can cause expansion and expansion. This results in the emergence of the desired secondary stresses around the connection. Did you know the cooling process on welded metal will go through the freezing process? If it is not properly observed, the process will cause the formation of fine holes due to the oxide reaction and separation. And after observing these three factors, the welding result obtained will be good and will not produce weld defect or shred on metal. Thanks for your attention. Goodbye.
Everybody fucking jump!